Hello everyone, in this video we're going to review apcalculus BC topic Taylor series and Maclaurin series. Alright, before we're going to dive into question, let's review some concept behind this topic. First, we're going to talk about the Taylor series. So, if the Taylor series is centered at s equals a, then we have f of s equals f of a over 0 factorial times s minus a raised to the 0 plus f prime of a over 1 factorial s minus a power 1 plus f double prime of a over 2 factorial times s minus a squared plus etc. Now, if a equals 0, then the Taylor series becomes Maclaurin series. Maclaurin series is a special case of the Taylor series. Now, substitute 0 for a over here, so we have the Maclaurin series is given by the formula f of s equals. Now, note that 0 factorial equals 1 factorial equals 1. So this guy can be written as f of 0 plus f prime of 0 s plus f double prime of 0 over 2 factorial s squared plus etc. The following are 3 Maclaurin series you need to memorize for the apcalculus BC exam. The first one is e to the s equals, it should be the sum when n starts from 0 to infinity of the general terms right here, s to the n over n factorial. Now, note that the interval of convergence of this series is negative infinity to positive infinity. Now, the second one, psi s equals, it's going to be the sum when n starts from 0 to infinity of negative 1 raised to the n times s raised to the 2n plus 1 over 2n plus 1 factorial. And the interval of convergence for this series is negative infinity to positive infinity. Now, the last one is cosine. Note that sin s is the arc function, right? So, the trick for you to memorize is, look at this one right here, 3, 5, 7, 3, 5, 7, something like that, right? The cosine is the even function, right? So it should be 1 minus s squared over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus etc. It should be the summation notation and start from 0 to infinity of negative 1 raised to the n s raised to the 2n over 2n factorial. And again, the interval of convergence of the series is negative infinity to positive infinity. You also need to memorize the following 2 geometries power series for the apcalculus BC exam. The first one is 1 over 1 minus s. It's going to be 1 plus s squared plus s cubed plus etc. plus s to the n. Now, if you want to put this one in summation notation, it's going to be and start from 0 to infinity of s to the n, right? And you know that the interval of convergence of this power series is negative 1 and 1, right? Now, the second one is 1 over 1 plus s. It's going to be 1 minus s plus s squared minus s cubed plus s to the 4 plus etc. plus negative 1 raised to the n s to the n, right? So, if you put this guy in summation notation, it could be n start from 0 to infinity of -1 raised to the n s raised to the n, and the involve of convergence is -1 to 1, right? Now, three popular questions that you mostly see on the apcalculus PC exam are: the first one, write a function in terms of a series or match a series to an appropriate function. Second, find an error bound on an n-degree Taylor polynomial. And the third one, find an interval or radius of convergence. Now, next one, we're going to talk about the error bound. So we have the error bound for the alternating series and non-alternating series. Now for alternating series, we're going to use the formula error equals absolute value of the actual value subtract the estimate value, which means s of infinity subtract s of n. And it's going to be the remainder. The remainder must be less than or equal to absolute value of the first omitted terms. So suppose we have the series -1 raised to the n minus 1 times 1 over n when n starts from 1 to infinity. If we start at 4, we have the s4 equals. If n equals 1, we have 1. N equals 2, we have -1/2. N equals 3, we have 1 over 3. N equals 4, we have -1 over 4, right? So, if we use this formula, we have absolute value of the remainder. It's going to be less than or equal to the next omitted terms. We mean absolute value of the next one right here should be plus 1 over 5. We're going to use this one. So it should be absolute value of 1 over 5. And it's going to be 1 over 5. So keep that in mind. Now, when it comes to the non-alternating series, we're going to use this formula right here. Now, in order to find the interval of convergence for Taylor series, we mostly use the ratio test. So here's the ratio test. You need to create the limit of absolute value of a sub n plus 1 over a sub n. And if we take this limit when n approaches infinity less than 1, the series converges. And then you're going to find the interval of convergence. If this guy greater than 1, the series diverges. If this guy equals 1, the ratio test fails. So you would have to use another test to determine the convergence or divergence. So keep in mind, when you use the ratio test for the interval of convergence, you only have the open interval, which is -a less than s less than a. So you would have to check the endpoints to see if the series converges at the endpoint. Now, if you use the geometric series to check for the interval of convergence, you don't need to check the endpoints, because by the geometric series, the series converges when absolute value of common ratio less than 1 is the same thing as -1 less than or less than 1, right? Now let's move on to question 1. Select the values of a function f and its first three derivatives are indicated in the table above. What is the third degree Taylor polynomial for f about s equals 1? The question wants you to find the third degree Taylor polynomial. Alright, so we're gonna stop right here, right? And the center at s equals 1 is tells us that a equals 1, right? So we have p3, right? Because we start at 3. Of s equals f of 1 plus f prime of 1 times s minus 1 over 1 factorial plus f double prime of 1 times s minus 1 square over 2 factorial plus f triple prime of 1 times s minus 1 cube over 3 factorial. Now, f of 1 is 2, right? Plus f prime of 1 is going to be negative 3 times s minus 1 plus f double prime of 1 is going to be 3, right? 2 factorial is going to be 2, so we have 3 over 2 times s minus 1 square plus f triple prime of 1 is going to be negative 2, right? And 3 factorial is going to be 6, right? So we have negative 1 over 3, right? Times s minus 1 cubed. So the answer must be B. Now let's move on to question 2. The third degree Taylor polynomial for the function f about x equals 0. It tells us that the center equals 0, right? TOS equals this guy, which of the following table gives the value of the function f and its first three derivatives at x equals 0, right? T3 of s equals f of a plus f prime of a times s minus a plus f double prime of a over 2 factorial times s minus a square plus f triple prime of a over 3 factorial times s minus a cubed, right? Now, center at s were 0, which means a equals 0, right? Substitute 0 for a, we have this guy right here equals f of 0 plus f prime of 0 times s plus f double prime of 0 over 2 factorial times s squared plus f triple prime of 0 over 3 factorial times s cubed, right? Now we given this guy right here, so we just put this guy down over here. Now we just match this guy up. F of 0 equals 3, right? Next one, f prime of 0 equals negative 4, right? F double prime of 0 over 2 factorial equals 2. So f double prime of 0 should be 4, right? And f triple prime of 0 over 3 factorial equals negative 3. So f triple prime of 0 equals 3 factorial times negative 3 is going to be negative 18, right? So all this is match this guy. Now let's move on to question 3. What is the radius of convergence of the series s minus 4 to the 2n over 3 to the n? Alright, so again, we're going to use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity, right? This guy right here, actually a sub n, right? So we have limit when n approaches infinity of absolute value of s minus 4 raised to the 2 parentheses n plus 1. Be careful. If you write 2n plus 1 like this, that's completely wrong, right? Over 3 raised to the n plus 1. Divide by this one, we're going to multiply by its reciprocal, right? So 3 raised to the n over s minus 4 raised to the 2n, right? So we're going to simplify this one. This guy actually 2n plus 2, right? So we have limit when n approaches infinity. Absolute value of s minus 4 raised to the power of 2, right? Over 3, right? Because 3 raised to the n and 3 raised to the n cancel out. Absolute value of s minus 4 square over 3, right? And we need this guy to be less than 1, right? So it's going to be absolute value of s minus 4 square less than 3. Now check square root both sides. Absolute value of s minus 4 less than root 3, right? So it's going to be negative root 3 less than s minus 4 less than root 3, right? Now we just draw the number line, right? Now observe that the center right here s equals 4, right? So we put 4 right here. Now if we solve this one, it's actually s less than 4 plus root 3, right? And this guy greater than 4 minus root 3, right? So right here 4 plus root 3 and right here 4 minus root 3, right? And the distance right here is greatest of convergence, which is root 3, right? The answer must be C. Let's move on to question 4. For s greater than 0, which of the following is the function of this power series, right? You know that the cosine function, the power right here should be even, right? The bottom must be even, so this is odd, this is not the case, right? Now B, the top should be odd, right? The bottom should be odd, but the top is even, so it's not the case. C, sin s over s, this one could be, right? Remember we have sin s is. So if I check sin s divided by s, and then this guy divided by s to be 1. This guy divided by s is going to be negative s squared over 3 factorial plus s to the 4 over 5 factorial minus s to the 6 over 7 factorial plus etc. So the answer must be C. Now let's move on to question 5. What is the coefficient of s to the 4 in the Taylor series for cosine square of s above s equals 0, right? So when s equals 0, it tells us that this guy is the Maclaurin series, right? So we have cosine of s equals. So if we need cosine square of s, this guy actually cosine s times cosine s, right? So does that mean this guy multiply by itself, right? But I don't recommend you doing this way because it's time consuming, right? So let's do this way. We have cosine of s equal this one, right? So what happened to cosine of 2s, right? So we just replace s with 2s as the big one minus 2s altogether square over 2 factorial plus 2s altogether to the 4 over 4 factorial minus 2s to the 6 over 6 factorial, etc. I'm going to simplify this one. It's going to be 1 minus 2 squared over 4 divided by 2 is going to be 2, so 2s squared, right? 2 to the 4 is going to be 16 divided by 24. It's going to be 2 over 3 s to the 4, right? Now, since we only need the coefficient of s to the 4, we stop right here, right? But this is cosine 2s, right? We need cosine square of s. Now, remember, we have cosine square of s equals 1 plus cosine 2s over 2, right? Also, sine square of s equals 1 minus cosine 2s over 2, right? So, I have cosine square of s equals 1 plus cosine 2s is actually this one right here, right? Divided by 2. 1 plus 1 is going to be 2 divided by 2 is going to be 1. Negative 2 divided by 2 is going to be negative s squared, right? And 2 thirds divided by 2 is going to be plus 1 third s to the 4, right? Now, the answer must be 1 third, right? Coefficient of s to the 4. The answer must be C. Now, let's move on to question 6. The function f has derivatives of all orders for all real numbers. And the fifth derivative of the function f is e to the psi s. If the 4-degree Taylor polynomial for the function f about s equals 0 is used to approximate the function f on the interval 0 to 1, what is the Lagrange error bound for the maximum error on the interval 0 to 1? Alright, so since this one is the non-alternating series, we're going to use the formula right here, right? And observe that this is the 4-degree Taylor polynomial for the function f about s equals 0. And then n plus 1 right here must be 5, right? So I'm going to copy this formula over there. Now note that n plus 1 right here actually 5 right here, right? And n equals 4, right? 4-degree Taylor polynomial, right? So I'm going to substitute. Now remember c equals 0, right? Center at 0. So we need to find the maximum of this guy right here within this interval, right? Now e to the psi s is maximum when psi s is maximum when s equals 1, right? The largest value of this interval, right? So we substitute 1 for s, and we have. Now we're gonna bring up the calculator, hit this button right here, input the absolute value side right here. Hit this button, input the fraction, e to the sine of 1 over 5 factorial. Hit control and the button right here, input the factorial, and then press control enter. It's gonna be 0.019. So the answer must be B. Question 7. Let f be the function given by Ls equals ln of 3 minus s, the 3rd-degree Taylor polynomial for the function f about s equals 2 is. So this guy is the center, right? So the center a equals 2, right? So we have the Taylor polynomial is given by the formula. Now you given the function f of s right here, right? So we need to calculate f prime of s first, right? So it could be, we're going to use the formula ln of u derivative is going to be u prime over u, right? So it could be negative 1 over 3 minus s, right? So then f prime of a, but a equals 2 right here. So f prime of 2 equals negative 1 over 1, right? So it could be negative 1. Now f double prime of s equals negative 1 over s minus 3 altogether squared, right? So then f double prime of 2 is negative 1. Now f triple prime of s is 2 over s minus 3 cubed, right? So then f triple prime of 2 equals negative 2, right? Now don't forget to calculate f of 2, right? So it could be ln of 1 is going to be 0, right? So we substitute this value into this formula and substitute 2 for a, right? Then we're going to end up with the answer B. Question 8. What is the polynomial approximation for the value of psi of 1 obtained by using the 5th-degree Taylor polynomial about s equals 0 for the function psi s? Alright, this is very simple, right? So we have psi s is given by the formula. Now we only need 5th degree, right? So we stop right here, right? So we have psi s is approximately s minus s cubed over 3 factorial plus s to the fifth over 5 factorial. Now we need to approximate sine of 1, right? So we have sine of 1 approximately 1 minus 1 over 3 factorial plus 1 over 5 factorial, right? And it's gonna be 1 minus 1 over 6, right? Plus 1 over 120, right? So the answer must be E. Now let's move on to question 9. What is the coefficient of s squared in the Taylor series for 1 over 1 plus s squared about s equals 0? Alright, so remember we have the Taylor series is going to be given by the formula. Now note that a equals 0, right? Substitute 0 for a over here. And we need the coefficient of s squared, right? So s squared, which means right here. So the coefficient is right here, right? So we have the function f of s is given by 1 over 1 plus s altogether square is actually 1 plus s altogether raised to the negative 2, right? So we have f prime of s is going to be negative 2 times 1 plus s raised to the negative 3, right? F double prime of s is going to be 6 times 1 s raised to the negative 4, right? Now s equals 0, substitute over here, so we have f prime of 0 equals 6, right? So we print it over here, so we have the coefficient f double prime of 0 over 2 factorial equals 6 over 2 is going to be 3. The answer must be D. Now let's move on to question 10. If f of s equals s times sine 2s, which of the following is the Taylor series for f about s equals 0? We have sine s is given by, now we have sine of 2s, just replace s with 2s, multiply both sides by s. So we have s sine of 2s equals, so the answer must be E. Now let's move on to question 11. A function f has Maclaurin series given by this guy. Which of the following is an expression for the function f of s? Alright, so look at the answer choice A, B, C, D, E right here. Answer choice A, B, C related to sine and cosine. Answer choice D and E related to e to the s, right? So remember the sine function is given by n. The cosine function is given by the given one right here has 2 factorial, 3 factorial, 4 factorial, right? So it cannot be A, B, C, right? Because you have 3 factorial, 5, 7, or 2, 4, 6 only, right? Now we have e to the s is given by, now look at D right here, we can factor s squared out. So we have e to the s minus 1, right? So I'm going to subtract s and subtract 1 both sides, right? So I'm going to end up with e to the s, subtract s, subtract 1, and then this guy gone. I'm going to have s squared over 2 factorial plus s cubed over 3 factorial plus s to the 4 over 4 factorial plus etc. Right? I'm going to multiply both sides by s squared, right? So I have s squared times e to the s minus 1 equals s to the 4 over 2 factorial plus s to the 5th over 3 factorial plus s to the 6 over 4 factorial plus etc. Right? So the answer must be D. Now let's move on to question 12. Let P of s equals 3s squared minus 5s cubed plus 7s to the 4 plus 3s to the 5th be the 5th degree Taylor polynomial for the function f about s. What is the value of f triple prime of 0? The coefficient of s cubed is given by f triple prime of 0 over 3 factorial in the Taylor polynomial expansion, right? Now we just match this guy up, negative 5 s cubed and this guy right here, right? So we have the coefficient at triple prime of 0 over 3 factorial equals negative 5, right? So at triple prime of 0 equals negative 5 times it could be negative 30, right? The answer must be A. Question 13. Let f be the function f of 3 equal to f prime of 3 equals negative 1, f double prime of 3 equals 6, and f triple prime of 3 equals 12. Which of the following is the third degree Taylor polynomial for the function f about s equals 3? So the center A equals 3, right? So we have P3 of s equals f of 3 plus f prime of 3 over 1 factorial s minus 3, right? Plus f double prime of 3 over 2 factorial s minus 3 squared plus f triple prime of 3 over 3 factorial s minus 3 cubed, right? We substitute values, right? So we have P3 of s equals f of 3 equals 2 plus f prime of 3 equals negative 1, right? So it could be negative of s minus 3. F double prime of 3 equals 6, so 6 divided by 2 could be 3, so plus 3 times s minus 3 squared. F triple prime of 3 equals 12, so it could be 12 divided by 6, it could be 2 s minus 3 cubed, right? So the answer must be A. Now let's move on to question 14. Let h be a function having derivatives of all orders for s greater than 0. Select the values for the function h, and its first four derivatives are indicated in the table above. The function h and these four derivatives are increasing on the interval 1 to 3. Question A. Write the first degree Taylor polynomial for the function h about s equals 2 and use it to approximate h of 1.9. Is this approximation greater than or less than h of 1.9? Alright, first we have the Taylor polynomial expansion for the function h is given by the formula where c is the center, so c equals 2 right here. Now we only need the first degree Taylor polynomial, right? So we have T1 of s equals h of c, which means h of 2 plus h prime of 2 times s minus 2. We stop right here, right? So this is the first degree. Now we substitute values. H of 2 is 80 right here. Plus h prime of 2 is 128 right here. Times s minus 2, right? Now we need to calculate T1 of 1.9, right? So it's gonna be 80 plus 128 times 1.9 subtract 2, it could be negative 0.1, right? Now if you use a calculator, this guy actually 67.2. We need to compare this guy right here with this guy. Since the second derivative of the function h of s is greater than 0 and increasing for s between 1 and 3, the function is concave up. So the tangent line is below the graph, right? It's going to be like this, tangent line is right here. Therefore, T1 of 1.9 less than h of 1.9, right? So the approximation is less than the actual value. Now let's move on to question B. Write the third degree Taylor polynomial for the function h about s equals 2 and use it to approximate h of 1.9. Alright, so we're gonna go back to this formula right here. the third degree Taylor polynomial, we're gonna stop right here, right? Now we need to use the value of this guy, this guy, this guy, and this guy from the table right here, right? And then we're gonna simplify it, right? So we have, now we need to calculate T3 of 1.9, right? So substitute 1.9 for S and use the calculator. The answer should be approximately. Question C. Use the Lagrange error bound to show that the third degree Taylor polynomial for the function h about s equal to approximates h of 1.9 with an error less than 3 times 10 to the negative 4. Now remember, the remainder for a third degree Taylor polynomial is for some z between 1.9 and 2 right here. This is c, right? This one is s, and z is between c and s, right? So maximum of this one when z equals 2 right here, because 2 greater than 1.9, right? So we have absolute value of the fourth derivative of h at 2 over 4 factorial, it could be 24, right? Times s minus 2, right? Now, the fourth derivative of h at s equal 2 is given right here. 584 over 9, right? So it's going to be 584 over 9 divided by 24, right? Times s right here equals 1.9, subtract 2, it could be negative 0.1, right? So when you raise to the 4, it's going to be positive, right? So I don't need to put this guy inside the absolute value sign anymore, right? Now you're gonna print up the calculator. Hit the button right here, input the fraction. Press Ctrl Enter. It's gonna be 0.00027, right? It's the same thing as 2.7 times 10 to the negative 4, right? And this guy actually less than 3 times 10 to the negative 4, right? Now let's move on to question 15. Let f be the function given by f(s) equals e to the negative s squared. Write the first four non-zero terms and the general terms of the Taylor series for the function f about s equals 0. So the center equals 0, and then this guy becomes Maclaurin series, right? And you know that e to the s equals, now you need to substitute negative s squared for s right here. So we have e to the negative s squared equals, and we need the general term, right? So plus etc. plus the general terms right here. So it could be negative s squared all together raised to the n over n factorial, right? Now we're going to simplify this one, so it could be, now we can use the general term right here to represent the function f(s) right here. So this guy actually the sum when n start from 0 to infinity of negative 1 raised to the n s raised to the 2n over n factorial, right? Now let's move on to question B. Use your answer from part A to find the limit of this one, right? So we have 1 minus s squared subtract f of s. It's actually 1 minus s squared subtract the whole thing right here, right? So I just copy this one down. Now I'm going to distribute negative 1 and I'm going to simplify. So it turns out to be, now I'm going to divide by s to the 4, right? So if I take this one divided by s to the 4, it's going to be this guy divided by s to the 4, and the same thing as this guy divided by s to the 4, right? So I'm going to end up with negative 1/2 plus s squared over 6 subtract etc. Right? Now I need to take the limit of this one. So I have limit of 1 minus s squared minus f of s over s to the 4 when s approaches 0. It's going to be limit of negative 1 over 2 plus subtract etc. Right? When s approaches 0, this guy approaches 0, the answer is negative 1 over 2. Now let's move on to question C. Write the first 4 non-zero terms of the Taylor series for this interval. Use the first 2 terms of your answer to estimate this guy. Interval form 0 to s of e to the negative t squared dt is interval from 0 to s. Now we're going to use Taylor polynomial expansion for this guy, which we did in question A, right? So it's actually antiderivative of 1 is going to be t, right? This guy actually t cubed over 3 plus t to the 5th over 10 minus t to the 7th over 42 plus etc. Evaluated from 0 to s. So it's going to be s minus s cubed over 3 plus s to the 5th over 10 minus s to the 7th over 42, right? So the first 2 terms right here. So the interval from 0 to 1 over 2 e to the negative t squared dt is actually s equals 1/2, right? So it's going to be 1/2 subtract 1/2 cubed divided by 3, right? So it's going to be 1 over 2 minus 1 over 24, right? So it's going to be 11 over 24, right? Now let's move on to question D. Explain why the estimate found in part C differs from the actual value of this guy by less than 1 over 200, right? So we have the absolute value of the interval from 0 to 1 over 2 e to the negative t squared dt subtract this guy right here 11 over 24, always less than the third omitted term, which is this guy right here, right? But s equals 1 over 2, right? So we have 1/2 to the 5th over 10, right? Now we're going to simplify. It's going to be 1 over 320, right? And this guy actually less than 1 over 200, right? Since this guy right here is an alternating series with individual terms that decrease in absolute value to 0, right? Now let's move on to question 16. Let f be a function with derivatives of all orders, and for which f of 2 equals 7. When n is odd, the derivative of the function f at s equals 2 is 0. When n is even and n greater than or equal to 2, the n derivative at s equals 2 is given by this formula. Question A. Write the 6th-degree Taylor polynomial for the function f about s equals 2. So the Taylor polynomial expansion is given by the formula. Now we have p6 of s equals. Now when n is odd, the n derivative of the function f at s equals 2 is 0, right? So n is odd right here, n is equal 1 for this one, right? The first derivative. This is the third derivative, right? N equals 3. This is n equals 5, right? And derivative equals 0, right? So we only care about the first one right here. It's going to be f of 2, right? The center s equals 2. So a equals 2. F of a is going to be f of 2. This guy right here equals 0, right? Now this guy right here, n equals 2. We're going to use the formula right here, right? So we have f double prime of 2 over 2 factorial, right? Times s minus 2 square, right? N equal 3, it could be 0. N equal 4, it could be plus the sixth derivative, right? Now we substitute value f of 2 equals 7 right here. Plus f the program, we're going to use the formula right here, right? So n equal 2, substitute over here, so we have 1 factorial over 3 square, right? Times 1 over 2 times s minus 2 square plus n equals 4, substitute over here, so we have 3 factorial over 3 to the 4 times 1 over 4 factorial times s minus 2 to the 4 plus n equals 6, it's going to be 5 factorial over 3 to the 6 times 1 over 6 factorial times s minus 2 to the 6. Now question B. In the Taylor series for the function f about s equal 2, which is a equal to, what is the coefficient of s minus 2 to the 2n for n greater than or equal to 1? Now observe that this guy right here, this guy right here, and this guy right here, they are the same, right? If I generalize this one, it's actually 2n derivative of the function f at s equal a over 2n factorial, right? Times s minus a raised to the 2n. Now the coefficient is this guy right here, right? Look, they ask you to find the coefficient. So we have, now in order to find this one, we look at the formula right here. If this guy n, this guy n, and this guy n, now we have 2n right here, so we just replace n with 2n, right? So we have, now we're going to simplify this one. 2n minus 1 factorial, rewrite this one, over 2n factorial can be written as 2n minus 1 factorial times 2n, right? Times 1 over 3 raised to the 2n, right? So this guy and this guy cancel out. We have 1 over 2n times 3 raised to the 2n. This one is the final answer. Now let's move on to question C. Find the interval of convergence of the Taylor series for f about s equal 2. Alright, so we're going to go back over here. The Taylor series is right here, right? This one is the first 6 terms, right? You know that the first term right here is going to be 7, right? And you look at the second term right here, you have the product right here. And this product actually right here, right? So we have, now in order to find the interval of convergence, we're going to use ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. It's going to be limit when n approaches infinity of, I'm going to let this guy right here be a sub n, right? So we have a sub n plus 1 is going to be, we need to multiply by this one reciprocal, right? So it's going to be limit when n approaches infinity, absolute value of, we have 2n on the top right here, so we have 2n right here over 2 times n plus 1 on the bottom. Now this guy right here actually 3 raised to the 2n times 3 square, right? So this guy and this guy cancel out. We have 3 square on the bottom, which is 9, right? And this guy right here actually 2n plus 2. So we can rewrite this one as s minus 2 raised to the 2n times s minus 2 square. This guy cancel out. So we have s minus 2 square, right? Now we're going to simplify 2 and 2, right? So this guy turns out to be, we're going to use the relative growth rate, right? So n grows faster than 1. So it's going to be absolute value of s minus 2 square over 9. Limit absolute value of n over n when n approaches infinity. And this guy actually 1, right? So we have s minus 2 square over 9, right? And this guy always positive, so I can remove the absolute value side, right? I don't have enough space, so I'm going to write over here. So it could be s minus 2 altogether square over 9 less than 1, right? So it could be s minus 2 altogether square less than 9. Take square root both sides, so it could be absolute value of s minus 2 less than 3, right? So it's going to be negative 3 less than s minus 2 less than 3, right? Add 2 3 signs, so we have negative 1 less than s less than 5, right? Now we need to check for the endpoints, right? So the first one s equal negative 1 and the second one s equal 5. S equal negative 1. Substitute negative 1 for s over here. So we have, so it's gonna be 7 plus this guy cancel out, right? I'm gonna bring 1/2 to the front, so it could be 1/2 series 1 over n when n start from 1 to infinity, right? Now since this one is the harmonic series, it's always divergent, right? So if this one diverges, the whole thing right here diverges, right? Alright, substitute 5 for s over here. So we have, if you simplify this guy, it's actually 7 plus the series 1 over 2n when n start from 1 to infinity. So this guy actually, the first case, right, it still diverges, right? If you rewrite this one as 1 plus 1 over 2 series n start from 1 to infinity 1 over n. This one is harmonic series, so this could be divergent, right? So if this one divergent, the whole thing divergence, right? So your final answer must be negative 1 less than s less than 5. Now let's move on to question 17. The Maclaurin series for the function f is given by this guy and converges to f of s for absolute value of s less than r, where r is the radius of convergence of the Maclaurin series. Question A. Use the ratio test to find r. Alright, so we have limit absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit. Right, let this one be a sub n. So we have a sub n plus 1 is going to be negative 3 raised to the n, right, over n plus 1, right, times s raised to the n plus 1 divided by a sub n. We're going to multiply by its reciprocal, right? So it could be, now we're going to simplify this. The bottom right here can be written as negative 3 raised to the n times negative 3 power of negative 1, right? So this guy and this guy cancel out, right? So negative 3 power of negative 1, I'm going to bring it to the top. It turns out to be negative 3 power of 1, so it could be negative 3, right? And over n plus 1 right here. Now this guy right here can be written as s to the n times s. This guy cancel out, right? So I only have s left right here, right? So it's gonna be absolute value of 3s, right? And in order for this series to be convergent, this guy must be less than 1 by the ratio test, right? 3 times absolute value of s less than 1. So it's gonna be absolute value of s less than 1 over 3. Now we look at this one right here, absolute value of s less than or. This guy absolute value of s less than 1/3. So we're going to match this guy. So the radius of convergence is 1 over 3. Now let's move on to question B. Write the first four non-zero terms of the Maclaurin series for f prime, the derivative of f. Now this one is the function f of s, right? So we just write the first four terms of the function f of s first, and then we're going to take derivative, right? So now we're going to take derivative of this one. It's going to be 1 minus 3s, right? Plus 9s squared, right? Bring 4 to the front, so it could be cancel out right here. Minus 27s cubed, right? Now this guy actually geometric series where the common ratio equals negative 3s, right? Because every single time you're going to multiply by negative 3s to get the net terms, right? So we have f prime of s equals the series k start from 0 to infinity of negative 3s raised to the k. And this series converges because we have this guy right here, absolute value of s less than 1 over 3, right? This guy actually absolute value of 3s less than 1. And this guy actually absolute value of common ratio less than 1, or absolute value of negative 3s less than 1. So by geometric series, the series convergent to a sub 1 over 1 minus r. It's going to be a sub 1 right here, 1 over 1 minus negative 3s, right? So it could be 1 over 1 plus 3s, and this guy actually the rational function, right? Let's move on to the last question. Write the first four non-zero terms of the Maclaurin series for e to the s. Alright, so we have e to the s equals 1 plus s squared over 2 factorial plus s cubed over 3 factorial, right? And this one is the first four non-zero terms, right? Now we're going to simplify this one. It's going to be 1 plus s squared over 2 plus s cubed over 6, right? Now use the Maclaurin series for e to the s to write the third degree Taylor polynomial for g of s equals e to the s times f of s about s equals 0. So we have g of s equals e to the s, which means 1 plus s squared over 2 plus s cubed over 6 plus etc. times f of s, which means s minus 3 over 2 s squared plus 3s cubed subtract etc. Right? So we just multiply this one out, right? So 1 times s is going to be s, right? 1 times negative 3 over 2 s squared is going to be negative 3 over 2 s squared. 1 times 3s cubed is going to be plus 3s cubed, right? S times s is going to be s squared, right? S times this one is going to be negative 3 over 2s cubed. S times this one is going to be plus 3s to the 4, right? And s squared over 2 times this one could be plus s cubed over 2. S squared over 2 times this one is going to be negative 3 over 4 s to the 4. And this guy times this guy is going to be 3 over 2 s to the 5th, right? S cubed times this one, it could be s to the 4, but we only need the third degree, right? So we can stop right here, right? Now we're going to simplify. S minus 3 over 2 s squared plus s squared is going to be negative 1 over 2 s squared, right? and 3x cubed minus 3 over 2 x cubed. It's going to be 3 over 2 x cubed plus 1 over 2 x cubed. It's going to be 2x cubed, right? This guy, s to the 4, we can ignore, right? Because we only need third degree, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand